Okay, this is number 25. We have a half-life at 1,599 years. We have the initial quantity at 10 grams. We are asked to find the amount after 1,000 years. So this is going to be A of 1,000. So we're going to use our growth model, or decay model in this case. So the amount present is equal to the initial amount times e to the kt. Now k is going to be negative. We're going to substitute the values in, the initial values, which is a quantity of 10 here. The half-life is the time in which half of it will decay. Our goal here is to solve the equation for k. So that should be 10. Oops, no, that's not correct. We want to get that. Okay, so we're going to put in k here and 1599. So because it's a half-life, you're always going to get a half there when you divide both sides. So e to the 1599k. Take the natural log of both sides. So natural log of 1/2 is equal to 1599k. So all right, k is going to be 1 over, actually the log of 1/2 divided by 1599. And you're typically going to see that written as negative log of 2 of 1599. So with that, we have our model. Okay, so having found k, our model now is A is equal to the initial amount, which happened to be 10, e to the minus log of 2 over 1599 times t. And we want to know how much is present in 1,000 years. So t is going to be 1,000. And if you plug that in your calculator, you get 6.482. Number 27, very similar. We've got a half-life of 5715 is the half-life. We have that there are 2 grams after, so A of 1,000 is equal to 2. So once again, we're going to start with our model. A is equal to the initial amount, e to the kt. K is going to be negative here. We're going to plug in our initial condition. So what we have in the half-life is A over 2 is equal to A e to the k times 5715. We're going to divide both sides by a sub 0. So once again, you see we have 1/2 is equal to e times 5715k. We're going to take the natural log of both sides. We get the natural log of 1/2 is equal to 5715 times k. So k is equal to negative log of 2. We're going to reverse that log of 1/2 over 5715. One word of caution here, you'll notice I started with e to the kt. K is going to be a negative number. If you start with e to the negative kt, you will work this out and get k to be a positive number, but either way the model is going to be the same. So at this point we've got the model being a of t is equal to a0 e to the negative log 2 divided by 5715 times t. Now, in order to find the initial amount, we still don't know that, we're going to take the amount present after 1,000 years, which we are told is 2 grams, is equal to a0 e to the negative log 2 over 5715 times 1,000. This quantity here is just a number, so a sub 0 is going to be 2 divided by e to the negative log 2 divided by 5715 times 1,000. So again, plugging this in your calculator, you get a0 is equal to 2.257.